Okay, and welcome back to my channel. I'm Jadi and we've reached to the localization and internationalization. Right, 3 because sometimes it's super useful and important and you may see bugs or unpredicted results from some scripts because of these concepts, the ones we're going to talk about. You should be able to localize your system in a different language than English and understand lang C and when it's useful. As you can see, there are lots of things here in the list, but they are kind of quick. Why do we need these things? Because we have an Earth which is huge and there are different continents. These are 3 continents and cultures here. People speak in different languages, people do have different character sets, and people do have different time zone. If this is London, this is considered the default time zone. But as you go to the east and west, time zones change and countries at the same time have different times on their clocks. Also nowadays we are speaking about having time zone for the solar things, for the Mars, for the, I don't know, other planets. And this is getting more and more complicated. Systems should be able to handle this. People should be able to change their language to the language they speak if they want to. Systems should understand the reference time and show the local time correctly, because you may want to check with someone, okay, we will start this activity at 12 o'clock. And say, okay, in which time zone? Computer should be able to solve this. Let's see what Linux provides for these obstacles. The easiest command is the date. Date will show my current date based on my current time zone. For fun, this is the time zone in Lagos, Nigeria. Cool. The time is this at Lagos. You also have the cal. Cal will show you the calendar. Cal is super cool. You can have cal-3. Will show you the 3-month calendar, previous and next and current. Or you can even have cal 1998, will show you the 1998 calendar. You can check where you've born, which day, whatever. This is cool. So we have the cal, we have the date. But date do accept lots of formatting strings like this. Say date plus a string. For example, %sign capital Y will show you the year in 4-digit format. M will show you the month. And as you can guess, D will show you the date. The Y is capital, the next ones are not. If you go with mandate, it will show you the list of the formatting things you can use. For example, you can see capital B, locals, full month name. C for century, super fun. So I can say, show me which century I am and then show me the month. This is fun, super fun. We sometimes use this to create some very common formats. Year, month, day, then underscore, for example, day, underscore, and hour, and minute, for example. This will give you a string indicating this moment's date and time. So sometimes when we want to create, for example, backup files, we use this character just above tab in my keyboard. We are talking about localization, and say touch backup blah blah, for example. And it creates a backup file with the current timestamp. So this is the usage of date. But we have a more general command. It is timedatectl. As you can see, it shows me that your current time zone is in Africa, Lagos. I just set it for fun. because it's a very fun country, cool country. I think for times it was the happiest country in the world. In the charts, I don't know how they calculate. Local time is this, but universal time, UTC, the old name was Greenwich or London time or Central Europe time, is this. And this is my difference in my location compared with the reference location. Also, I'm using a service which is called NTP to get the exact time from the servers. So this is how you can check more info about your current time. And this is fun. But to configure your time zone, we used to have a command tzconfig, which is not there in most cases, but we have tzselect, because when you are installing your Linux, in most installers it will ask you what is your time zone. You choose from a map or from a menu, you will choose your correct time zone. You can right click on your clock, change your time zone, or from your settings. But on the command line, if you want to select the new time zone for one of the programs, you should go with tzselect if you don't know your time zone. Tzselect will give you a menu. You say, okay, for example, I say I'm in Indian Ocean. These are the time zone there. I'm on Maldives. Cool. And it says, is this correct? You are on Maldives? I said, yes, sure, I'm in Maldives. And it tells you, okay, if you want to change your time zone to Maldives, this is the configuration. Set the TZ time zone variable to Indian Maldives and then export it. If you want to make this permanent for your user, put this in your .profile. So every single shell will have this configuration. So I can do this, and from now on, the commands I will run, if they check the time zone, they will see Indian Maldives. If I go with a date, you can see that I'm on Indian Maldives +5. Another method, because this is just a variable, tzselect will show you this variable. So another method is exporting it directly. For example, here I have the tz, I have, for example, say env, tz equals, I have Asia, Tokyo there, and then run the date command. It says, okay, based on the Japan time, at the moment it's 20:30. So we had different methods. We had a general time zone on the system configured. We have not touched it yet. I was able to use tzselect to change my time zone to something, but I would get a variable like this. And whenever I put this afterwards, if the programs ask about time zone, this will be my new time zone. Or I was able to directly say my environment is this and then run this command. 3 different methods. But where the default time zone comes from? The default time zone comes from a file in etc local time. If I do an lsltrh, you can see that my etc local time is a short link to user share zone info Africa Lagos. If I check this file, it will tell you that this file is a binary file, which is a time zone data. Version 2, no GMT time flags, no blah 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 data. But it's not a text file, it's a time zone file. If time zone in some country changes, if decided not to have the daylight saving time or whatever, they will update this file. So if I go to etc, user share zone info, all the time zones are here. For example, UTC or universal, Zulu time zone. US has some fun time zones like Indiana Straga or Mountain time zone. So if I want to set a new time zone, I can say env US/mountain time. Or you can copy one of these files on the local time zone, because you saw that this is the current system-wide time zone. So I can go to etc, say unlink etc local time. So I don't have any local time at the moment if I was root. And then set a new time zone. I would say ln-s from user user share zone info US mountain time on the local time. So I create, it's root again. So it created etc local time and it points to this. The reason that I don't copy the main file and instead I create a short link is because if this time zone changed based on the decisions from the US government, the next update will update this file based on the new decisions. For example, they may change the daylight saving. So in this case, my time zone will work correctly because this is linking to the main file. But if I would copy this here, the update on the distro would update this, but my copy was not affected. So it's better to create links and it's cleaner. So my new time zone is on the mountain time. If I go with date, because I have a tz variable set. If I create a new bash and go with date, this is inherited. So if I go with onset tz and then go with date, I'm on mountain time zone. I unsetted the value. Cool. This was all about time zone. But let's have a talk about language. Again, different countries do have different locals. In different languages, some things might be different. For example, your language might write the date like this, 1st of January 98. Mine might say 98 1st January. And if it was the 19th of the January, it was more obvious. For example, different standards. This comes from a variable called lang. If you run the local, you will see that there are different configurations for locals. For example, my lang is English US variant and I'm using UTF-8 character sets. For example, where is the date format? My time format is English US variant UTF-8. When a program wants to print the date, it may check this and based on this configuration decides how to show the dates. Should it show it like this, year, month and day, or it should show it like year, day and month. So different things. Or for example, in many cases people complain that my printer always thinks that my papers are a letter sized papers. I prefer them on A4 format. This is from US. So when saying LC paper, my local paper is set on the English, US and UTF-8. So it goes with this as a default. I could change this one only to, for example, ENGB UTF-8 and I would use the standard from GB. This is how it works. And there is one variable LCall which changes all of this. If this is set, computer won't check for any of this. So if I want to run a program, I can change my local to something else and my new program, if understands locals, will use that one. Even this is possible that different programs might have translations for different languages. So if I change my lang, my interface might change to, for example, French, because my lang is on French France UTF-8. This is a fun way to change it. And the general configuration comes from, I have it somewhere. I don't know where it is. Anyway, it's here. Cat etc local conf. Here it says my general configuration for the whole computer is here. If I want to change this, I can change the LCall and lang or whatever you want. LCall will override all of these to something else in my .bash rc or better in my profile, so I will have it each time a shell spawns. This is how you can configure this, and always you can unset if you don't want it. But there is one specific one which you should know about, and that is lang equals C. Here lang equals EN, US variant UTF-8. It is very custom to see lang equals C in many scripts. Why is that? C here refers to C programming language. I wanted to say in the beginning Unix was written in C. In the beginning Unix was written in assembly, but still Linux and most of our tools are written in C. The reason that some scripts do have this in the beginning is to have a coherent, predictable environment to work. There might be a language in which B comes before A. I don't know such a language, but there might be. For sure, there is a language in which date comes before mount when we're talking about dates. When you are scripting, this can make some confusions, because if your program running a sort, you want to be sure that always A comes before B, not in some weird language. Respect the cultures. Not in some specific language, it's vice versa. Or if you want to print something, you want to make sure that you are always printing in one specific format. That's why you sometimes export lang equals C in your scripts to make sure that your output is what you want and it's not in some other countries or other regions specific configurations which makes your program to have errors. This is why you have this export lang C in some places. To add locals, sometimes you need to install new locals. Sometimes there are updates for them. If you are on a Debian, you have the dpackage reconfigure locals and you can change them. And also you have this file. It was here. Also you have this file to change your default local. At the end, let's have a quick chat about the character encoding. In the beginnings, computer did have only access to their ASCII character. In the memory, there were in the beginning 1 to 8, later 2, 5, 6 characters. A was one of them with a specific code. You know, computer has everything like a 0 and 1. Every 8 of these will make 1 byte. And each byte, when described as a character, was one specific character. For example, A is 65, if I'm not mistaken. Long time not doing these things. Space is 32. So from 1 to 8, all the main ASCII characters were here. Capital letters, small letters, numbers, punctuations, anything. After this, from 1 to 8 till 2, 5, 6 was the extra characters. For example, something like a this, whatever it is called, tilde. We don't have this. Anyway, different characters were here. And this was all you could print. If you wanted to speak about any other language with other characters, you have to change your encoding. One of the most famous encodings was ISO 8859. This had more characters like Thai characters, Arabic characters, and some more characters used in different texts, and it gave you much more than what you had in ASCII characters. So this was a standard for a long time. But later it came UTF-8. With UTF-8, practically you have all the characters from all the spoken and unspoken language, in addition to some signs. For example, you have this, you have this, you have this. These are the characters, not some images here. And lots of other fun things. So UTF-8 is what we use nowadays practically, and while we are on UTF-8, we practically can forget in most cases about the character encodings. In older times, when you would go to a web page, you may see strange characters which you don't understand. from view encoding, you have to choose the correct encoding, so the page would change to what you can understand or to the correct language. Anyway, UTF-8 solved this, and now on UTF-8 we practically have all the required characters plus lots and lots of other things, symbols, everything. So life is much easier. At the end we have one command. It is iconv, converts the character encoding. If you have a file which is in one specific format, you can change it to another format using iconv. Here I say iconv -f from Windows 1258 was one of the famous and mostly used ones to UTF-8. This file will convert this file from this format to this format. It is not used that much anymore, but it is sometimes super duper handy. If you go with iconv-l, it will show you all the formats it understands, and you can see that there are a lot. Even in the CTF competitions where I play hackerish games, sometimes you reach to some file at the end from one mainframe and you see, okay, I cannot read it. And you search and see, okay, that specific mainframe used that specific file format, and now I need to understand CP 1079. You just use iconv from this to UTF-8, your file, and voila, you win. Have fun. It was joyful. Hope you liked it. I had to scroll this one. Hope you liked it. And let's go to 108.